this video, I'm going to review functions for our final. We're going to start with domain and range. Domain, as a reminder, is all the x values that are included in the graph. So it's all the x values included in the graph. The range is all the y values included in the graph. We use domain and range to describe functions and what values are included for functions. To tell if something is a function or not based on the graph is we do a vertical line test. So if we can draw infinite vertical lines that only intersect the graph in one place, then we know that that graph is a function. So this graph on the right here is a function. And that test that I just did is the vertical line test. It's the vertical line test. I want to talk about what's the domain and range for this graph, and I want to say, is it a function, yes or no? Well, I already said, yes, it is a function. I just did the vertical line test, and it worked. And then for domain, I'm looking from the left to the right. I'm scanning for all the included x values, and I'm starting with my lowest x value, which, because this goes on and on and on and on forever to the left, I know that my lowest x value is negative infinity. Since this goes on and on and on to the right, I know that my highest x value is positive infinity. And I put parentheses on both because parentheses means not included, and I cannot include infinity. For the range, I'm looking at the y values from the bottom of the graph to the top of the graph. I'm scanning. What's the lowest y value? And the lowest y value is going to be negative infinity. And the highest y value, notice that I stop here. The highest y value is 2. So my range is negative infinity to 2. Negative infinity has a parentheses on it, and 2 has a bracket because 2 is included. This point here is included in the graph. So I indicate that with the bracket. For number 2 here, I want to talk about what's the domain of this function. And basically what I need to do is think about what is not allowed for x, like what can x not be. And the only restriction when I have a fraction, so I know this thing is a fraction, the only restriction is in the denominator. I know that the denominator can't equal 0. Can't be equal to 0. So because I know the denominator can't be equal to 0, I know that x plus 9, what's in the denominator, can't be equal to 0. And I'm just going to solve that non-equation for what I know x cannot be equal to. I'm going to subtract a 9 on both sides, and I'm going to find that x cannot be equal to negative 9. So I know x cannot be equal to negative 9, which means everything else is included except for negative 9. So I'm going from negative infinity all the way to negative 9 for the domain. And then I'm going to have another interval, negative 9 to infinity, because everything is included except for negative 9. So to indicate that, I would have a interval for the left-hand side of negative 9, and then I would have an interval to the right-hand side of negative 9. Right. For number 3, I have f of x is equal to 1 over the square root of x minus 4. Just like the last example, this is a fraction, and I have a variable in the denominator. So one restriction that I have here that I need to keep in mind is that the denominator can't be 0. Another restriction I have to keep in mind, since I see this x inside of a square root, is that a square root, the restrictions for a square root, is that square roots cannot have negatives inside. or else it's not a real number. So keeping both of those things in mind, I know that x minus 4, the square root of that, cannot be equal to 0. And I know that the square root of x minus 4 from the second restriction has to be greater than or equal to 0. So since it can't be equal to 0, I know it just has to be greater than 0, and then I can ignore that. Then what I'm going to do is I'm going to square both sides to get to what's inside of the square root. I have x minus 4 has to be greater than 0. And then I add 4 on both sides of this inequality, and I get that x has to be greater than 4, which I show in interval notation. I show that the lowest value is 4, and the highest value is infinity. And I put a parentheses on 4 because 4 is not included. The next thing I'm going to talk about is lines. The form that we use most of the time is called slope-intercept form, and I know that is y equals mx plus b. For y equals mx plus b, we need two things. We need the slope and we need the y-intercept. Sometimes the slope isn't going to be immediately given to us, so we need to know how to find it. The formula for slope is the change in y over the change in x, or you can write it as y2 minus y1 over x2 minus x1, whichever you prefer. The slope-intercept form, y equals mx plus b, the m represents the slope, and the b represents the y-intercept. And I actually see these things in the title of this form. So slope is here, and the intercept is here. The other forms that we talked about were point slope form and standard form. I'm going to talk about point slope form next. Point slope form is y minus y1 is equal to m times x minus x1. And the m here, again, is slope, and the x1 comma y1, this is a point on the line, any point on the line. So here I see it's point slope form. I have the slope and I have a point. This is the point, x1, y1. The other form that we talked about was standard form. Standard form is, you can write it like this, ax plus by equals c, or you can write it as ax plus by plus c is equal to 0, where a, b, and c are integers. Something that's important in standard form, no fractions are allowed. No fractions allowed in standard form. For number 8, I have, I have 2 points, and I want to find all of these things. This should be B, A, B, and C. First of all, when I'm given 2 points, the first thing I always want to do is find what the slope is. So I'm looking for the change in y to the and the change in x. So from 1 to 3, negative 3, I want to know what's the change in y. That's the change in y. The change in y is from 1 to negative 3. I know that I am subtracting 4, so the change in y is negative 4. Then I want to find the change in x, so I'm going from 8 to negative 2. That's the change in x. I know the change in x is equal to, if I go from 8 to negative 2, I've subtracted 10. So the change in y over the change in x, or the slope, is equal to negative 4 over negative 10, or just positive 4 over 10, because the negatives cancel each other out. I can simplify this to, if I divide the top and bottom by 2, I would get 2 over 5. So the slope is 2 over 5. I want to write the equation in point slope form. So point slope form I know is y minus y1 is equal to m times x minus x1. So I'm just going to plug in all the information that I know. The m I know is 2 over 5. And then I just pick one of these 2 points. I'm going to pick the one that only has positive numbers, and I'm going to plug it in for x1, y1. So 8 comma 1 is x1, y1. X1 is 8, y1 is 1. And then I just plug in the rest of the formula. So I have y minus 1 is equal to 2/5 times x minus 8. And this is my point slope form. For b, I want to write the equation in slope-intercept form. So what I can do is I can just take this form and change it. I want a slope-intercept form. The important thing about it is to have y by itself. So I'm going to start with y minus 1 is equal to 2/5 times x minus 8, and then I'm going to get y by itself. First thing I'm going to do is I'm going to get rid of this denominator of 5. So what I want to do on the left-hand side is I want to multiply by 5 over 1 to get rid of that 5 in the denominator. If I do that on the right-hand side, I'm going to do that on the left-hand side. I'm going to multiply by 5. I'm going to distribute that 5 to the y and to the minus 1. So I'll have 5y minus 5 is equal to, I have the 5's here are going to cancel out. I'm going to be left with 2 times x minus 8. Remember that this is all multiplication, so this 5 here only cancels out, or you're only multiplying it to that fraction in the front of the parentheses. Then I'm going to distribute this 2 to the x and to the minus 8, and I'll get 2x minus 16 on the right-hand side. So I'll have 5y minus 5 is equal to 2x minus 16. I'm going to add 5 on both sides to eventually get the y by itself. I'll end up with 5y is equal to 2x minus 11. And then I'm going to divide everything by 5 to get the y by itself. So I'll have y is equal to 2/5 x minus 11 over 5. And this is my slope-intercept form. To write the equation in standard form, I'm going to take the slope-intercept form, and I am going to get rid of the fractions. So to get rid of the fractions, I'm going to multiply everything by 5, both sides. And I'm going to distribute this 5 to this term and this term. I'm going to end up with 2x minus 11 is equal to 5y. And then I'm just going to get my x term to the other side. So I'll just subtract 2x on both sides. And I will get 5y is equal to, 5y minus 2x is equal to negative 11. And this is an example of standard form. The next thing I'm going to talk about is absolute value graphs. I'm going to start by talking about the absolute value equation with transformations, the transformations applied to the parent function. If I see a coefficient, this tells me what the slope is. It tells me the vertical stretch or the slope of my graph. If I see something being subtracted inside of absolute value bars, I know that tells me if I'm moving to the right or to the left, depending on if h is positive or negative. If I see something being added on the outside, it tells me if my graph shifts up or down, depending if it's positive or negative. And if I see a negative in front, it tells me that there's a reflection over the x-axis, or that my v shape is flipped upside down. You graph absolute value functions by finding the vertex first, which is going to be h comma k, h being the thing that you subtract inside of the absolute value bars, and k being what you add on the outside. And then after you find the vertex, so you find your shift, right and left, up and down, then you apply the slope. And remember that these are v shapes. So absolute value functions are v shapes. So let's try to graph one. I have y equals 1/2 times x minus 2 minus 1. I want to think about all the transformations that I have here. First of all, on the outside, I have minus 1. This tells me that I'm moving down 1. I also have minus 2 inside of absolute value bars. This tells me that I'm moving right 2. So if I see something being subtracted inside, I know I'm moving to the right. And then this 1/2 on the outside tells me that the slope to the right-hand side of my vertex is 1/2. So the change in y over the change in x is 1/2. I'm going up 1 and then right 2. I'm going to first graph my vertex. So the first thing I wanted to do is find the new vertex. The new vertex is based on the fact that from 0, 0, I'm moving down 1 and to the right 2. So my new vertex is going to be at 2, negative 1. This is my new vertex, 2, negative 1. And then on the right-hand side of that, I'm going to be going up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And this is the right-hand side of my graph. I know that absolute value functions are symmetrical over the vertex. So there's a line of symmetry here, and I can find the other points on the other side of the vertex by just reflecting over that line. So I notice that this point here is 2 away from the line of symmetry. So I have another point 2 away on the left, because that was 2 away on the right. I have a point 4 away on the right here, so I have a point 4 away on the left here. And now I can connect all of this, and it's the V shape for that absolute value equation. For number 13, I'm going to look at all of the things that I have. First, before I can do that, I don't see the y by itself, so specifically I'm going to need the y by itself for me to be able to use transformations. So I'm going to get the y by itself by adding 1 on both sides of this equation, and I'll end up with y is equal to negative 2/3 times x minus 2 plus 1. And then I'm going to look at the transformations there. So first thing I notice is I have plus 1, which means I'm moving up 1. Why is that green? I'm moving up 1. I also see minus 2 inside, so that means I'm moving right 2. And I also see a negative 2/3 on the outside. Well, yeah, okay. Negative 2/3 on the outside. And why did I make that color? This color. Which means my change in y over my change in x is equal to negative 2 over 3. And that's the right-hand side of the vertex. So first thing I want to do is find what's the new vertex. The new vertex is, I'm going to move up 1 to the right 2, which means from 0, 0, I'm moving up 1 to the right 2, and I'm going to be at the point 2, 1. And that's right here. And then to the right of that, I'm going to be doing the slope down 2 to the right 3. So down 2 to the right 3 gets me at this point here, down 2 to the right 3. I can't do that again. So this is the right-hand side of my graph. Should be a straight line. And then I know that it's symmetrical over the vertex. So I have another point. This is 3 away from that line of symmetry to the right. And so I have 3 away to the left as well. And then I finish that V shape, and there's my graph for that function. The next thing I'm going to talk about is absolute value inequalities. Absolute value inequalities, I have, first of all, what I want to talk about is the line itself. When I see less than or equal to or greater than or equal to, I know I have a solid line. So I have a solid line. When I have greater than or less than without an equal to sign, I know I have a dashed line because it means that the line itself is not included. Solid means the line is included. So I put a dashed line when it's not included, solid line when it's included. For shading, if I have greater than or equal to or greater than, I know I'm shading above the line. And for less than or equal to, I know I'm shading below the line. I'm going to do this example here. I have y is less than the absolute value of x minus 3 plus 1. First thing I'm going to do is I'm going to write the guideline. So the guideline that I'm going to be shading above or below. And that just means I just change the less than sign to an equal to sign. I have y is equal to the absolute value of x minus 3 plus 1. And then I'm going to graph that thing. Before I actually graph it, I want to talk about, should the line or should the graph be dashed or solid? And since it was just less than and not less than or equal to, the absolute value function itself is not included. Everything below it is. So it's going to be a dashed graph. And then I want to talk about where am I going to shade? Well, y is the less than. So if I see y is less than, I'm going to be shading below. Now I can actually graph this equation, this guideline, and I know that it's going to be dashed. I have to keep that in mind. I have inside of absolute value -3 and outside +1. So I know I'm moving right 3 and up 1. And I'm going to do that, and I'll end up at right 3 up 1 right here. That's my vertex. And then the slope, I don't see a slope. I know it's 1/1, or just 1, because I don't see a number. I know there's a 1 in front. And that means I'm going up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the left 1, up 1 left 1, up 1 left 1. And this is my graph. Oops. I did something wrong. I am supposed to be dashing this. So I'm supposed to have a dashed function. And then I took care of the dashed line, and I'm going to be shading below. So I should be shading everything that is below this absolute value graph. And this is my solution set. So every point in the shaded region, and that shaded region is infinite. Next thing we're going to talk about is solving absolute value equations and inequalities. When solving absolute value equations, the first thing we're going to do is isolate the absolute value. So we're going to isolate the absolute value. Then we're going to split our problem into 2 equations. Remember to always check your solutions. You're going to check for extraneous solutions, which means solutions that don't make sense. Check for extraneous solutions when you have these types of problems. Okay, sometimes you might solve and get something that doesn't actually work. Over here, I am going to do this problem. I have -3 times the absolute value of x minus 1 plus 2 is equal to 8. I'm going to first start by subtracting 2 on both sides. I'm going to get -3 times the absolute value of x minus 1 is equal to 6. And the reason why I am subtracting 2 is eventually to get this isolated, that absolute value isolated. Then last thing to get the absolute value isolated on the left is to divide by -3. I'm going to end up with the absolute value of x minus 1 is equal to -2. The absolute value cannot be equal to a negative number because absolute value is distance and it needs to be positive. So this is actually no solution. If it did make sense, if this part made sense, I would say x minus 1 is equal to -2 or x minus 1 is equal to +2. And then I would solve those 2 equations. But since that statement doesn't make sense, I stop there and I say no solution. Absolute value can't be negative. Next, we're going to talk about absolute value inequalities and how to solve those. First, when you have the symbols less than or equal to, you think of them as an and symbol. So you think less than. This reminds you that it is an and problem and that the graph will look like this. So it should look something like this. You have 2 points and then you have shaded in between those 2 points. Most of the time. When you have symbols greater than or greater than or equal to, you think of them as an or symbol, and it will look like something like this. So you usually have 2 points and you're shading outside of them. Now this isn't always the case. Sometimes you'll be shading the entire line, and it'll be all solutions. So you either have that or you have this. And for and, you either have that or you have no solution, nothing shaded, because it doesn't make sense. So make sure you're shading in the right direction and you're looking at what your solution is and if it makes sense. Here's an example. I have -2 times the absolute value of x plus 1 is greater than -6. First thing I'm going to do is isolate the absolute value, which is what I do for equations too. Divide by -2 on both sides. I'm going to, before I do anything else, because I divided by a negative, I'm going to change the sign. I'm going to flip it to be less than instead of greater than. I'm going to end up with the absolute value of x plus 1 is less than 3. And then what I'm going to do from there is now that my absolute value is isolated, I'm going to write 2 inequalities to solve. just like I would have written two equations to solve for an absolute value equation. The first inequality looks exactly the same as this, except drop the absolute value bars. I have x plus 1 is less than 3. And the other one would be x plus 1 is I flip the sign. Instead of less than, I have greater than, and I flip the other side to its opposite, so greater than negative 3. Since this was less than, I know that I put and in between. So it's x plus 1 is less than 3, and x plus 1 is greater than negative 3. From there, I'm going to subtract 1 on both sides from both of these inequalities, and I'm going to get x is less than 2 and x is greater than negative 4. And then I'm going to graph this. So I have negative 4 and 2 on a number line, and it says less than and greater than. So I have open circles on these. They're not included, and then I am shading everything in between. So all numbers in between are solutions. We also talked about adding, subtracting, multiplying, and dividing functions. So we're going to practice that. If you're adding two functions together, so let's say you have f of x is equal to x plus 2, and you have g of x is equal to x squared, you can add these two functions together. If you have f of x plus g of x, you're just going to add the expressions x plus 2 plus x squared together, and you can't combine anything there, so it's just x squared plus x plus 2. You usually write highest power first. For f of x minus g of x, you're doing x plus 2, that's what f of x is, and you're subtracting g of x, so you're subtracting x squared. And so that would be negative x squared plus x plus 2, and this would be how you write it. And then you can also multiply functions together. So when you're multiplying, you want to put both things in parentheses. F of x is x plus 2. I put that in parentheses. G of x is x squared. I put that in parentheses. It doesn't really have to be in parentheses, but then I distribute the x squared to both terms, and I get x cubed plus 2x squared. And that would be the answer for multiplying the functions together. And then if I wanted to divide the functions, I would have f of x, which is x plus 2, divided by x squared, and nothing cancels here. I can't cancel an x in the top and the bottom because of the addition that I see in between terms in the top, so this would just be my answer like that. I also need to know how to find the inverse of a function. The first thing that I do to find an inverse is I flip x and y, and then I solve for what my output is, which is y. So I solve for y, my new output. An example of that is if I wanted to find the inverse, this is what it looks like written, of f of x is equal to x plus 2. I would first start by changing this to y is equal to x plus 2. I would change my x and y, so I would have x is equal to y plus 2, and then I would get y by itself. So I'd subtract 2 on both sides, I get that y is equal to x minus 2. After I did that, I would replace a y with the inverse of f of x, and this would be the inverse of f of x. The inverse is the opposite of the original, so notice in the original I was adding 2 to the input. The inverse is the opposite, subtracting 2, so I'm doing the opposite to the input for an inverse. And the last thing I'm going to talk about with functions is systems. So there are 3 possible situations that can happen, and they have specific vocabulary that goes with them. I'm going to draw a picture and write words to describe each case. So the first case is one solution. That means that I have 2 lines that intersect in only one place. So they only intersect in one place. This means, I should go over the vocabulary. So consistent, so I have consistent means there's a solution, and inconsistent means that there is no solution. If something has a solution, you also have to talk about if it's independent or dependent. And independent means that it has only one solution. Independent, that is a solution by itself. And dependent means it has infinite solutions. So infinite solutions. And those are the things that you need to specify. So if it has a solution, you need to say if it's independent or dependent. So for this, I know it has a solution, so it's consistent. And I know that it has one solution, so it's independent. Okay, for no solution, that would look like two lines that are never going to intersect. They never intersect, so they're parallel to each other. That would mean it is inconsistent. It doesn't have a solution. Inconsistent. And then I don't have to specify if it's independent or dependent because it doesn't have a solution. The other situation is infinite solutions, which means that I have infinite solutions. The lines are the same. The two lines that I have in the system are the same. They overlap each other. This means they have a solution, so it's consistent, and it's not independent because it's more than one solution. It's dependent because it's infinite solutions. I want to do an example of solving a system. So I'll have maybe 8x minus 5y is equal to 17, and 4x minus 15y is equal to negative 29. And I want to solve for x and y. So first thing I'm going to do is I'm going to rewrite... do I have to change both of them? No, I can make the second equation. I want to use elimination, so I want to add these two equations together and cancel something out. Right now, I can't cancel anything. 5y and negative 15y don't cancel. 8x and 4x don't cancel if I add them together. But if I were to multiply the second equation by negative 2, then I would have negative 8x, and then that would cancel with 8x. So I'm going to just rewrite this system as 8x minus 5y is equal to 17. And then I'm going to change the second equation. I didn't change the first equation at all. I'm going to change the second equation to negative 8x plus 30y is equal to, and then negative 29 times negative 2 is positive 58. Now I'm going to add these two equations together, and the 8x and the negative 8x are going to cancel out, and I'm going to be left with 25y is equal to, I have 75. And then I'm going to divide both sides by 25, and I'm going to solve for what y is, and that's going to help me get what x is. So I have y is equal to 3. That's one of my answers. And then I plug that into whichever equation I want. So I'm going to use the top equation. I'm going to have 8x minus 5 times 3 is equal to 17. That's 8x minus 15 is equal to 17, which means 8x is equal to 32. And then that means x is equal to 4. So I've solved for x and y, and I put it in a point form. So 4, 3 is my answer.